Right, let's have a look what's going on. The average is 25 and the standard deviation is 9. What happens if I multiply every score by 5 and I add 10? Are the numbers 5 times more spread? What's going on? So if I had the numbers, say I had some numbers and it was reasonable, I could go, oh, I had 5 and 12 and I don't know, I got to get something reasonable, 20, 31 and 43 or something like that. If I multiply every score by 5 and add 10, so 25 plus 10, 35. Multiplied by 5, 60, add 10, 7. Multiplied by 5, 125, add 10, 135. Multiply 5, 155 plus 10, 165, 215, 225. Are these numbers more spread than what the original were?
Yeah.
How much more spread?
5.
So from here to there, if these were correct figures, which they're not, was 38, whereas here to there will be?
190.
190, well done, mate. So they're 5 times more spread. So what happened to our mean on this one? I should just write it here. Let's go. B of 5x plus 10 is what?
135.
Times that by 5, which is what Ray's saying. 125 and add 10 is 135. Yeah? So the numbers are 5 times bigger and then you added 10 to them. That's harder to do. Your brain's got to think about it. Standard deviation. They are how much more spread? 5 times more spread. What's standard deviation about? How spread they are. So if I could spread the numbers out 5 times as much, so the standard deviation was 9. What's it become?
45.
45. Now the big one, the variance.
Square it. Oh, is it not plus 10?
Yeah,
Doesn't
Does plus 10 have any effect on variance and standard deviation? No. Say it again. Does plus 10 have any effect on variance and standard deviation? No. It only has an effect on the expected value, the mean or the average. So what do we times this by? The standard deviation of that was 9. So the variance of that would be?
81.
81. So the variance of this would be 81 times by what?
5.
Not 5.
10.
Not 10.
Oh, 25.
100.
Wait,
What?
25.
5 squared.
Yeah.
Now some of you are going, yeah, nah. I feel like I should do another one of those first before I do minuses. So I'm going to change this. I'm going to make that 3x plus 2. What's that going to be? 3x plus 2. Does plus 2 affect the average? Yes. So each of these scores are 3 times bigger and add 2. 3 times bigger
75.
plus 2.
77.
Does the variance get affected by plus 2? No. Does the standard deviation get affected by plus 2? No. Standard deviation gets affected. It was 9. So we're going to multiply it by
3.
3. So that's 77. Variance is different though.
81.
81 times by 9. Could say 9. I'm going to nag about 3 squared. So what happens if I did minus 3x?
Why wouldn't you just do 27 squared? Because I think that's easy to understand.
Or just, but you don't know that standard deviation.
Yeah, but you get it from.
But can you say 9 cubed? No. Yes. That's.
I think I know what your question is, but I'm going, no, I'm not sure. Why didn't you write?
That's a really nut.
So
27
for question 1, you could have just put 45 squared instead of 81 times 25.
Oh yeah,
So
you're right, aren't you? This is 9 by 5 all squared, so you're saying this for those who don't catch it. 81 times 5 squared is 9 squared times 5 squared, which is 9, which is 45 all squared.
Well, we know that SD squared is variance. VAR.
So you could do that. So what's this going to do?
Make them
do this one. Let's say that was then
Negative
3
3.
times bigger. 15 with a negative. 3 times bigger.
36,775.
93.
93.
I should have made up lots of
129.
numbers. I should have made up numbers. 8
129.
and 29 with a negative. So what's it done to the spread?
Triple it.
Triple it. So wait a minute. Does it matter that they went from positive to negative? How far from there to there again? 38. How far from there to there?
Negative 38.
100.
38. Because it's,
What?
Not 38, it's 3 lots of 38.
yeah.
Which you meant, I know what you meant.
14.
What's that, 90?
114. 114.
114.
Did it matter whether it went that way negative? It's standard deviation is not about whether they're negative or positive, it's just about how far is it from there to there. 114. So what happened to the standard deviation? It was 9, now it becomes 9 times by,
Negative 3.
not negative 3.
3.
No?
9 3 is 27.
Okay.
What happened to the variance? It was 81. Does the minus matter? No. You times it by 3 squared. What happens to the mean? Now it matters. So all those numbers now, as an average, instead of being 38, what's it going to be? No, well, it's 38. Instead of 25,
Negative
Minus
75.
minus 25 times by 3. So you could write it as minus 25 times 3 if you wanted to.
Or just negative 75.
You okay with that? You can get what the figures are. Now a step further. Now can you, for a moment, no, she's
Is that half of x?
yeah,
Okay.
yes.
Wouldn't it still work if the variance and the standard deviation is negative? Because like that still makes sense.
Oh, you could call them the negative of it. Is that
But
what
you wouldn't
mean?
put that, yeah.
No, you wouldn't put it.
No, as in you write the answer as a negative 81 times 9. Would that make sense?
I don't know.
Would you get marks for that?
Because it's a variance of negative.
Yeah, because the variance, if the
Negative.
variance is negative, it's the same as like.
Standard deviation of
Yeah.
negative 27. That doesn't not make sense.
It's to measure a spread, not a matter of direction. It's not like vectors
Yeah.
where you're looking at what direction it is. I'd probably leave it as that. Standard deviation, all the numbers were halved. So what's it do to the standard deviation? Halves the standard deviation. So what do? The standard deviation was 9, and I multiply it by a half. What's the variance then? The variance was 81, and what do I multiply it by this time? A half squared. Good. The average, we're going to halve everything and minus 8 from it. So it was 25, so we're going to halve that and we're going to subtract 8 from it. This is the one that most people get wrong, is that one there. Okay?
Why do you square it?
Because variances are squared times bigger than every than
I know why it's 81, but why do you square the half?
how do I put that into words? Other than me talking about when we go back to when you get the deviations and the deviation squared, everything is a squared too big. So this, when we get the average of it, is a variance. How much too big is it? Everything squared. So, yeah,
Yeah, okay.
I've been thinking about how to explain that for years. So the standard deviation is just times by a half. The variance is times by a half squared. I'm going to go through this for a second. This will not answer your question, but answer it. Standard deviation got times by 5. There it was, times it by 5. Standard deviation got times by 3. Standard deviation got times by 3. Standard deviation got times by half. The big one, variance got times by the same as that, but it was 81 times 5 squared. So for standard deviation it's times by 5, variance times by 5 squared. Standard deviation times by 3, variance times by 3 squared. Standard deviation times by half, variance times by...
So you can
Half
just
squared.
make it quicker by going 4.5 squared. No. Yes.
Well, we'll leave it there on that in terms of concept, we'll go on something else in a moment. But you could have said that's 9 by a half squared,
Yeah.
which you're saying is 4.5 squared, yes. Is that an advantage?
Do 4.5 squared.
So you go, well, that's 9 on 2 squared, it's 81 on 4. So as long as you're doing an 81 on 4. So, if you multiply by 10, what happens to the standard deviation? No one else answer? Multiply by 10,
What?
Is it 385?
Your head gets multiplied.
I mean,
No, it's not.
no, 45
the
squared.
standard deviation gets multiplied by 10. If you multiply by 20, standard deviation gets multiplied by?
What
If you multiply by a third,
20.25.
He was like,
if you multiply by a third, what happens to the
45
variance?
squared.
yeah, 2,225.
Yeah, it's not 3. Yeah.
Which is a 9. If you multiply by 5, what do you do with the variance? Multiply by
25.
25. Multiply by 7.3, what do you do with the
14.9.
variance? No, multiply by 7.3 squared. Enough said.